press the bell icon on the YouTube app and never miss another update.
Hello dear students. So let me continue center of mass part 7 lecture. Okay. So in this lecture again let me continue some more concepts from center of mass. Anyhow, in the last class we know some methods to locate center of mass. So we started method of location of center of mass. See, there are 4 methods. Okay, generally 3 are enough. Okay, based on situation I will use 4th method also. So the main 3 methods are method of symmetry, method of decomposition, method of integration. Okay, one more is there, Pappus theorem. Okay, so that is useful for only for few objects. So anyhow, method of symmetry already started. We know if 2 circular discs whose radius r1 r2 they are in contact with each other, then there will be a shift in center of mass. Okay, and we calculated center of mass of the system from the center of the bigger disc and from the center of the smaller disc also built in. And later we covered if 2 rods are joined to form as a T shape, again we got the center of mass, and 2 hollow cylinders whose radius is r1 r2 are joined end to end, and in that case also I calculated center of mass. Okay, now let me continue. Just a minute, its voice. Yeah. Now let me continue some more formulas based on center of mass. Okay. See, they given a wire whose length is L. If a wire of length L, see this is the wire whose length is L. A wire of length L. Okay, see the next concept. Okay, maintain the notes. See the next concept. A wire of length L is bent. Okay, generally the center of mass is here. If it is uniform mass, uniform density, okay, center of mass is at that point, at the center, at the midpoint of the wire. If this wire is bent into the form of a circle of radius r, okay, now see, once it bent into the form of a circle, then the center of mass will shift. Okay, if it is bent into the form of a circle, center of mass will shift. Center of mass will come to the center of that circle. Okay, see this is the center of mass of that wire. Okay, wire is bent into the form of a circle, and whose radius if it is taken as a r, then the distance of center of mass. Okay, just you cut this wire, and if it is straightened, this is the initial center of mass and this is the next center of mass. So this r will give distance of center of mass, that nothing but shift in center of mass. So we can write length of this circle, we can write length is nothing but 2 pi r. So 2 pi r, what is this r? R nothing but the shift. So let me write xcm, shift in center of mass. Then what is the shift in center of mass? xcm is equals to L by 2 pi. So keep the concept in mind, very basic concept. Okay, very easy level thing. If a wire of length L bent into the form of a circle, then the shift in center of mass nothing but the radius, and the shift in center of mass is L by 2 pi. Okay, take this L by 2 pi. And see, they given again a uniform rod, a thin rod or a wire. Okay, see, they given the same, a uniform rod whose length is L, uniform rod of length L. So a uniform rod whose length is L. Initially the center of mass is here. Initial center of mass is at the midpoint of that uniform wire having uniform density. So this is the wire whose length is L, if it is bent at the midpoint such that the two parts make some angle. Okay, let me repeat. So maintain the words. A uniform rod of length L. Okay, this is the uniform rod of length L. A uniform rod of length L bent at the midpoint such that two parts makes an angle theta, such that the two parts makes an angle theta. Maintaining the words. Okay. See these wire. See the wire is bent like this. I am drawing here. Now the two parts makes an angle theta. This is the initial center of mass. If the wire bent at the midpoint, then how much this part? How much this part? This is L by 2. How much this one? L by 2. Okay. So L by 2, L by 2. Now where is the center of mass of this part? Note out, center of mass of this part is at the midpoint of this wire, and for this also at the midpoint of that wire. So center of mass is here. Let me write C1. What is that C1? Center of mass of this wire. At what distance from the initial point? It is at a distance of L by 4. Okay. This is L by 2. And how much this one? L by 4. And here this is the center of mass for this part, C2. See, initial center of mass is here. Once it bent, now the center of mass of this part is at here and this part is at this position. In between them there will be a center of mass of this system. If I join a line, then the center of mass is along the line joining between the two center of masses. So there will be a center of mass here, because equal length, equal mass. Now the center of mass is at the midpoint. So this is the center of mass. Initial center of mass is here, final center of mass is at this place. So there will be a shift. Very easy thing this is actually. Okay, I am taking long. So this is the initial center of mass and this is the final center of mass. So there will be a shift, means we need to find from here to here. If I give it any name like O, if I give a name like A or B, whatever, then O to this point I need to calculate. So use simple geometry. See, join a line. Yeah. See, this is theta. How much this value? Theta by 2. Is it clear? Theta by 2. Yeah. This part is theta by 2. O to cm is, this is x, nothing but x cm. Okay, x. See, I am getting one triangle. Okay, let me zoom little bit. So I am getting one triangle like this. See, this is theta by 2 and see, this is 90 degrees and this is x. Okay, x, and how much this one? L by 4. Just little zoom this diagram now. X, L by 4. Now use, see, this is the normal. This is the normal here. Then use the sin theta cos theta systems. So from this is the adjacent side, this is the hypotenuse. So let me write cos theta by 2. Cos theta by 2, which is equivalent to how much? X by L by 4. So what is x? X nothing but center of mass. Okay, you can write xcm. xcm, shift in center of mass. So xcm. So what is xcm? L by 4 cos theta by 2. So this is the shift in center of mass when a uniform rod of length L bent at the midpoint such that two parts makes an angle theta in between them. Okay. Now the shift in center of mass formula, keep in mind xcm L by 4 cos theta by 2. Okay. So if you are good in mathematics, this is nothing. Okay. Okay, carry on now. XCM is equal to L by 4 cos theta by 2. First, suppose if these two parts are makes an angle 90, if these two parts are perpendicular to each other, okay, there is a wire bent at the midpoint, okay, bent at the midpoint, you apply some force, bent at the midpoint such that the two parts are looks like this, then we can find easily. If the two parts are looks like this, how much the theta value? Theta becomes 90 degrees, substitute theta 90 degrees here. If two parts are perpendicular, theta becomes what? 90 degrees. Then XCM is equals to L by 4 cos theta by 2, cos 90 by 2, cos 45. So 1 by root 2. 1 by root 2 means what? L by root 2. If they bend some 120 degrees, okay, these two parts will make like this, something 120 degrees. Substitute 120 degrees, 120 by 2, 60. So L by 8 you will get. Okay, cos 60, 1 by 2, and 1 by 4 is there. Okay, so I covered only one thing, a wire of length L bent into the form of a circle, then we got shift in center of mass. And the same wire of length L, if it is bent at the midpoint, if those two parts makes an angle theta in between them, then the shift in center of mass is L by 4 cos theta by 2. Okay, so easy things these are, nothing is there here. So anyhow, let me continue, let me enter into the next method to locate center of mass. So tell me, what is the next method? So apply this knowledge for other type of problems. Okay, whatever I covered that may come or may not come in the entrances, they may give some different, so feel concept wise. So use this knowledge to solve some other questions. Okay, anyhow, let me continue one more method, that is method of decomposition. Method of decomposition. Some division part, some cutting part. Okay, purely for entrances. Okay, all type of entrances. Useful for JEE. Okay, this knowledge I need, KSET, all. Yeah, method of decomposition. Let me give one example. See, they will give some plane lamina. Let me write one problem. Find coordinates of center of mass of a given plane lamina. Plane lamina nothing but a rigid body, okay, of mass, let us take some 3 kg as shown in figure. 3 kg as shown in figure. So I am giving one simple problem again. See, is it okay visible? Yeah. Okay. See, this is the plane lamina. Same model is there in NCERT. So I am targeting NCERT and all type of entrances. Okay, slowly I am going to cover everything based on first PU student especially. So they given L. See, this is the plane lamina. Okay, plane lamina. Okay, whose length is given L, and they cut like this. Plane lamina nothing but a rigid body. Okay, and given sigma. What is this sigma? Mass per, sigma is given having uniform density. So mass per unit area. Sigma is the mass per unit area. So they given a plane lamina having uniform density. Uniform density. That is mass per unit area. Yeah, see, the mass of this one is given. Mass of this one, see. Mass of the plane lamina is given how much? 3 kg. Let us divide this plane lamina into some parts. If you want to divide into 3 parts, you can divide into 3 parts. Okay, anyhow it is a uniform plane lamina. If you divide this into 3 parts, each part becomes 1 kg, 1 kg, 1 kg. If you divide into 2 parts, one part becomes 2 kg, another part becomes 1 kg. Okay, you divide into 3 parts or 2 parts. Okay, your wish. Follow the method first. Here, this is the plane lamina. Let me divide this is into 2 parts. Okay, let me divide this is in 1 part. This I am taking part 1. Let me write M1. This part along y-axis side I am taking part 1. Okay, you can take this part as a 1, this part as a 2, or divide into 3 parts, your wish. And this part, let me take 2, part 2. Okay, this length is clear, L. Okay, length is how much? L. So M1 is how much? Because it is a, they given 3 kg, na? So M1 we can write directly 2 kg. M1 we can write directly from the diagram, 2 kg. M2, 1 kg. But decide the coordinates of that M1, coordinates of M1. So coordinates of M1 means you identify the x coordinate of this M1 particle, M1 plane lamina, y coordinate. Let us see what is that x1 coordinate and y1 coordinate. See, from, if this is the origin, yeah, anyhow this is the origin only, this is x axis. This is y-axis, origin, and see, this is x1 coordinate, and what is this? Y1 coordinate. Because entire mass of this lamina is at the midpoint. At the midpoint of this means what is the entire mass? Center of mass. Okay. So this is x1, this is y1. What is x1? So this is L. This is L by 2. What is x1? L by 4. L, and this is half L by 2. This is another half L by 4. So directly you can write L by 4. Coming to the y1. Y1. See, complete is L. This is half part. Half part. How much? L by 2. Okay. So y1 is L by 2. Now coming to the M2. That is 1 kg. Okay, if mass is not given, we will use this sigma and other system. Okay, I will give you one more example also. X2. X2. X2 is the coordinate of center of mass of second mass. Entire mass of this lamina is concentrated at this point. Now, X2 is, okay, you can take from origin. Okay, I am finding coordinates from origin only. X2 up to here is L by 2, and how much this value? See, this is quadrant part L by 4. This is L by 4 and this is L by 2. Actually, L minus this value. Okay. So, how much this value? L by 2, and this is L by 4. Quadrant part 1/4. L by 4 plus L by 2. So, what is X2? L by 2 plus L by 4. L by 2 plus L by 4. See, X2 is L by 2 plus L by 4. How much it is now? So, 6L by 8. How much it is now? 3L by 4. Okay. Coming to the Y2. Y2 is this height. This is L by 2. How much this one? L by 4. Okay. L by 4. So, L by 4. Got x1 y1, got x2 y2 and m1 m2. Then what is our target? xcm ycm. Okay, if they ask the position vector xcm I cap plus ycm j cap. So what is xcm? xcm is m1 x1 plus m2 x2 by m1 plus m2. m1 x1 2 into L by 4. 2 into L by 4 plus m2 x2 1 into 3 L by 4. 1 into 3L by 4. M1 plus M2 3 kg. M1 plus M2 is 3 kg. So 2L by 4, 3L by 4, 5L by 4, 4 3 is 12. So how much it is now? 5L by 12. 4 3 is 12. Okay. Coming to the YCM. YCM M1 Y1 2 into L by 2. 2 into L by 2. M2 Y2 1 into L by 4. 1 into L by 4 by total mass 3. How much this now? So this is okay, directly we can cancel 4 and 1 5. Again I am getting same 5L by 12. Okay, no problem. So what are the coordinates? XCM and YCM, anyhow uniform density. So you are getting same XCM YCM same uniform density and uniform lamina this is. So what are the coordinates now? XCM and YCM is 5L by 4 and also sorry, how much it is? 5L by 12, 5L by 12. If they ask to find RCM bar, position of center of mass, if they ask, then what you are going to do now? XCM I cap plus YCM j cap. If they ask to find the magnitude, of position of center of mass, then you know how to extend root of XCM square YCM square. See, this is the method of decomposition. Okay. Let me give one more example to get some confidence, especially for some students. Okay. Yeah, completed. Okay, now let me run. Yeah, I'll give you one more problem. Okay, write down the question. Locate the coordinates of center of mass of a plane lamina as shown in figure. Locate the position of center of mass, that's better. Coordinates, position, nothing. So locate the position of center of mass of a plane lamina as shown in figure. Or you find coordinates, okay, anything. So locate the coordinates and also position vector of center of mass as shown in figure. So I am going to give the diagram. Okay, whatever may be the diagram, just I am using one given data. They may give any type of model. So here sigma is given, sigma is the mass per unit area, areal density. They given the numbers, this is 0, 10, 20, 30. So 10, 20, 30, 10, 20, 30, 40. Okay, no problem, take it. They may give like E-shaped thing, okay, they may give one more body here, they can give anything. And here they given sigma is the areal density, nothing but mass per unit area. Okay, there are three types of densities: linear density, areal density and volumetric density. Okay, that I am going to continue in method of integration. See, they given this diagram. Your target is to identify mass of each piece and coordinates of each piece. Okay, if you are divided this part into some 3, you will get m1 mass, m2 mass, m3 mass. m1 will have x1 coordinate, y1 coordinate. m2 have x2, y2. m3 have x3, y3. Now let us decide the masses and coordinates. Okay, decide the mass and coordinates. Let us see. Let me divide this into 3 parts. Okay, you can divide into any manner. Let me take this part. Okay, for our convenience, I am taking complete one part is. This is m1 mass I am taking. Okay, earlier also I followed the same thing. Now let us follow the one way to avoid some confusion. M1 part. This is M1 part I am taking. And this part center of mass is here. Let us take M2 part. This part, only this piece whose center of mass is M3. Means concentrated here, the mass of that piece is M3. So I divided the lamina into 3 pieces. You divide in any manner. You can take like this M1 and this is M2 and this is M3. Okay, no need to take how I am following here. Okay, you can take in any manner, but identify the mass, identify the coordinates. Okay, here I am taking, earlier I followed in like y-axis now, so again I follow the same M1. And this piece is M2, this piece is M3. If you want, you can take this is M1 above, downside is M2, this piece is M3, nothing will happen. Okay. Now, coming to the M1 mass. Is mass is given here? No, but they given density. Okay, areal density, sigma is given. Let us convert this mass into some density term. Okay, so sigma is what? Mass per unit area. Let me write M1 as sigma into area. What is M? M as sigma into area. What is this sigma? Mass per unit area. Now M1 we can write as, M1 is, sigma is the constant. Okay, it is constant for this given lamina. Area of the first piece, area of this piece is length into breadth. What is the length? If it is length 10, breadth is some 40. Okay, side into side, 10 into 40, how much area? This is a 10, this is 40. So how much the area? 400. So I got M1 value. I got M1 in terms of sigma. Okay. Okay. Now what is next target? Decide the x1 coordinate and y1 coordinate. X1, y1. So x1 is the x coordinate of center of mass for the first body, for the first mass. See, this is x1. This is x1. Have you seen this? This is x1. Starting is 0, ending is 10. Middle value is x1. What is the middle value? 5. 0, 10. The middle is 5. What is x1? x1 is 5. x1 is 5. Otherwise starting value plus ending value by 2. Starting is 0, ending is 10. Starting plus ending value by 2, middle value is 5. What is x1? Is x1 is clear? 5 is clear? So what is x1? 5. If it is a meter, meter, centimeter, centimeter. Okay, given proper units. Coming to the y1. y1 is very clear, 20. This is y1. y1. Where is the center of mass? From the origin, it is at a height of 20. Otherwise starting value 0, ending value 40. Starting is 0, ending is 40 by 2. 0 plus 40 by 2, 20. So what is y1? y1 is very clear. y1 is 20. y1 is 20. x1, y1 clear. Now coming to the m2. m2 is sigma into a2. This is a1, this is a2. So sigma a2, area of this piece, this lamina, this piece, small piece. So this length is how much? This length. Don't think 30, this length only. Take this piece outside. What is the length of this piece? This is 10, 10, 20. Okay, don't take this as a 30, figure is 30, but what is the length of this piece? 20. What is the height of this piece? 10. What is the area? 20 into 10. How much now? 200. Okay. Coming to the x2. Get the x2 coordinate. x2. Yeah, decide x2 and y2. y2 is very clear. This height only. 5. This is y2 and x2 is this much. Decide it, how much it is. y2 very clear. y2 is how much? This one from this, see, up to here is 10 and this is the half part, 5. y2 is 5. y2 is 5. Then decide the x2. x2. Okay, don't tell 20. It's not a 20. Check it once. Yeah, is it 20? Yeah, I think 20. Yeah, it's 20 because it's uniform. See, starting value of this piece is 10, ending value is 30. Starting value, ending value. Then how much it is? Starting value, ending value is 10 plus 30, 40, 40 by 2, 20. So x2 is 20. x2 I am getting 20. Or otherwise, in one more way, up to here is 10. Okay, see, up to here, just take this piece. What is the length of this piece? Length of the piece, how much? Yeah, 20, correct. Length of the piece is, this is 10, 10, 20. 20 means what is the center of mass of this piece? 10. Length is 20. Just you take this piece outside. 20. Length is how much? 10. 10 and from starting how much? 10. So what is x2? x2 is 20. y2 is 5. Okay. Otherwise for this block just you see starting value, ending value by 2. For this block only 10 plus 30 by 2, 40 by 2. So x2 is 40. Sorry, x2 is 20. Sorry. And y2 is, this is 0 and this is 10. This is 0 and 10. Along x axis 0, above is 10. 0 plus 10 by 2, 5. So y2 is 5. Let us decide the m3. Sigma into a3. Sigma a3. What is this size? So this size is only, this is a 10, this is a 10. See, this is the, what is the gap? 10. This is also 10. 10, 10. How much now? 100. Coming to the x3. Yeah, x3. See, here the 10 value, here 20. I told how to get x3. Starting, ending by 2. 10 plus 20 by 2. 10 plus 20 by 2. This is x3. Okay, if you want to take from the starting, this is what? 10. 10 means what is the middle point? 5. 5 and from origin how much? 10. 10 plus 5, 15. Otherwise 10 plus 20 by 2. 10 plus 20 by 2. Starting value plus ending value by 2. So how much it is now? 15. y3. y3. y3 is this much. Okay. This is y3. Okay. How much? y3. This height. See, up to here is 30 and center of mass of this one is 5. See, this is 30 and 40. The middle point, middle height is how much? 5. So, otherwise, starting value for this piece 30. Starting value of this M3 piece is 30. Ending value is 40. 30 plus 40 by 2. 70 by 2. How much it is now? 35. 35. Observe carefully. Directly we can expect 35. 30 plus 40. So, for this piece, the initial value of this piece is 30. Final value is 40. 30 plus 40 by 2, 35. 70 by 2. So, we got M1 x1 by 1, M2 x2 by 2, M3 x3 by 3. Okay. Then, what is the next target now? XCM. I think you know how to find this one. M1 x1, M2 x2. Let me substitute the values and I left it for calculation to you. So, what is M1? 400 sigma. M1 is 400 sigma, x1 5 plus M2 200 sigma, x2 20, M3 100 sigma, x3 15, M1 plus M2 plus M3 400 200 100. So, 700 sigma. See, constant is cancelled out. Here sigma is there. You can take sigma outside. Okay, you can take sigma outside. Otherwise, let me do XCM at least. Okay, you verify the calculation, that is your duty. So, take some 100 common, sigma common. 100 sigma, let me take common. If I take 100, 4 5s, this is 20. 100 already taken out, 220, this is 40. 100 already taken common, so this is 15 and this is 700 sigma, zeros gets cancelled out, sigma gets cancelled out, okay, 40, 60, 75 by 7, this is x coordinate, okay, if you want you can cancel 7 ones, 7 something, okay, XCM. Similarly, you try to find YCM, that is left to you only, do correct calculations, you know, multiplication and addition, division. So, substitute M1 by 1, M2 by 2, M3 by 3. Just target how to write M1 and how to write coordinates. Remaining, okay, everyone can do. Okay. So, I got XCM some value. Similarly, you find YCM. You try to find YCM. Substitute value M1 by 1 plus M2 by 2 plus M3 by 3 by M1 plus M2 plus M3. You will get the same. Again, sigma is going to be cancelled. You will get any number. Find YCM. So, YCM means M1 Y1. Let me just cross check. You continue YCM. So, M1 Y1 420. Sigma is there. Everywhere 100 common. So, 100 sigma. I will do roughly 4 to 80. And M2 200 already 420. So, 2 and 5 10 100 common already 35 700 sigma. So, 80 90. See, this is how much now? So, 80 90 100 110, so 125 by 7, verify, just I did roughly 45, 80, 125, just verify that numbers. If you want, you can strike off 7 1s or 7 some values. Okay. Now let me continue some more questions, some more concepts. Okay, they may give E shape or whatever, maybe you identify masses and you identify the coordinates. Okay. Now see the next one more concept. shift in center of mass if some part is cut. Okay, generally we can call it as a cavity. If any hole is there, we can call it as a cavity. Cavity name will come in every entrances like JEE and all other entrances. Okay, I am going to continue those models, concepts with problems. Yeah, I think this is completed. I am taking so much of time. Yeah. Now let me find shift in center of mass. If some part is cut from a circular disc, if some more disc is cut from a circular disc, if a square is cut from a square, a circle cut. Okay, there are different types of models. Let me continue few here. So let me find shift in center of mass. So see in a general way, see this is any one lamina, any one rigid body whose mass is capital M. Okay, whose mass is capital M. This is a plain lamina, otherwise a rigid body whose mass is how much? Capital M. From this, some part is cut like this, whatever may be the shape. Okay, some part is cut whose mass is small m. Whose mass is small m. Small m is nothing but what? Removed mass. Initially the center of mass of this lamina is at here. Initial center of mass is at the center. And if we cut some circular part, any other part, center of mass is at that center only, C2. And if this part is removed, then what about the center of mass? Will it shift right side or left side? No doubt center of mass will shift left side because this part is cut. Center of mass will shift left side, nothing but negative. Okay. So this is the initial center of mass, this is the center of mass of the removed part. If the D is the distance between them, then center of mass will be shifted to some left side based on this diagram. Okay, see this is the position of center of mass. To find this center of mass, okay, use the same like a sum of moments of masses about center of mass is 0. Otherwise, let me write here one formula to solve problems directly now. Say I want to get the center of mass from this one. From what? If this is a M1, if this is M2, I think you remember the formula. M1, M2 are separated by a distance D. If M1 particle, M2 particle, M2 mass are separated by a distance D. If you want to find center of mass from M1, then what is our formula? M2D by M1 plus M2. I think you remember. So XCM is equal to what is our regular formula? M2D by M1 plus M2. Okay. M1 plus M2. Here M1 minus M2 I am writing now because this part is removed. M1 minus M2. So what is M2 here? M2 nothing but mass removed. Removed mass into distance. What is this D? D is the distance between two center of masses. M1 is the total mass. M2 is the removed mass. So I am going to use this formula to solve some concepts or some problems. So keep this formula in mind. Whenever some parts are cut in a given diagram, you can use this formula. Mass removed into distance by total mass minus removed mass. Okay, generally that mass we can convert into area. Area we can convert into radius. Based on the given shape, we can convert mass into area and radius. So keep the formula in mind. To find the shift in center of mass, we are going to use now mass removed. This is nothing but our formula, regular formula, M2D by M1 plus M2. Here cut, some part is cut, I am using M1 minus M2. If any part is added, M1 plus M2. Now mass removed into distance by total mass minus removed mass. keep the formula in mind, mass removed into distance. Directly we can write, no need to remove or remember the formula. Just you follow the process, you will get the answer. Okay, for our convenience I am using this formula, mass removed into distance by total mass minus removed mass. Now let me continue one easy thing. Okay, so maintain the words. So write down the words, a circular disc of radius r. Write down, a circular disc of radius r. Okay, a circular disc of radius r from which radius you can take capital R, from which another circular disc of radius small r is cut. Regular question this is. Okay, another circular disc of radius small r is cut as shown. I am going to cut that part. A circular disc of radius capital R, from which another circular disc of radius small r is cut. So another circular disc is, let us suppose this is the another circular disc. It looks like circle. Yeah. Yeah, this part is cut. This is nothing but a cavity. Okay, this radius is r. Yeah. Then find shift in center of mass. So target is find shift in center of mass. Shift in center of mass. See, initial center of mass of the disc is C1. This is the initial center of mass. And center of mass of this cutting part is here. Once this part is cut, okay, if this part is cut, then center of mass will shift left. Okay, this is the center of mass, shift in center of mass. Okay, shift in center of mass, XCM. Then what is our formula? XCM is equals to, okay, here this is the total mass. Okay, M total, and this is what is this? M removed. Now let me continue. What is total? Total mass, nothing but volume into density. Okay, they given uniform thickness. Thickness is same, T. Rho is the density. Okay, uniform density. This volume and density we can write it as area into thickness into density. So what is the area? Area of the bigger one is pi r square T rho. So total mass varies with what? Only capital R square. So total mass varies with capital R square. Total mass. In the same way, what is the removed mass? Removed mass also like a disc. Removed mass also like a circular disc. If it is a plate, you can take the plate area. Now removed mass also is a one more circular disc. So no doubt that removed mass, nothing but it is proportional to area. That area proportional to pi r square. R nothing but small r. So r square. Then substitute the proportionality values here. Otherwise you can use complete value. So the constant values available in the numerator and denominator, that will be cancelled out. Otherwise you can use proportionalities. So XCM is equals to removed mass proportional to what? R square. Mass removed, it is proportional to r square. I am using proportionalities. If you are interested, you write all the things, constants will be cancelled out, nothing will happen. So removed is r square into distance. What is distance? D is the distance between these two centers. D is the distance between two centers. You write as it is D, because we don't know how much this value. If they given this capital R, if they given small r, we can get capital R minus small r will give some value. No, that is not possible in this situation. Next I will give you. Total mass r square removed small r square. See, this is the answer. This is the shift in center of mass. Okay, this is the shift in center of mass. Anyhow, this is shift left side, na? You can take negative. Okay, So shift is here negative, because it is shifting left side, you can take negative. See, don't confuse about this negative and positive answers. Okay, generally I am going to get every time positive, okay, but here the shift is left side, so answer is negative. In a given paper, in a question paper, if you observe the two options, one is positive answer, other one is negative answer. Whenever the part is cut, if they given two options, one is a r square d by r square minus r square, other one option is given in a fourth option minus r square d by r square minus r square, then tell me which option is correct, whether positive answer is correct or negative answer is correct. No doubt negative answer is correct, because the part is cutting out and shift is left side, so the correct answer is negative, minus r square d by r square minus r square. If negative option is not available in the given question paper, then you can go for r square d by r square minus r square. Okay, so in physics most of the problems, if negative is not available, generally we can choose the positive option. Okay, if both options are available, 99%, 100% negative answer is correct. Means based on the given problem, it's not possible for all. For this shift, negative is correct. Okay. Okay, don't follow the negative for all type of questions. That is also not easy, not possible. For shift case, okay, negative shift. If I use the regular format, I'll get negative, like m into x, m into m1 x1 m2 x2. If I use, I will get the negative. But this is the way, easy way to identify the answer, r square d by r square minus r square. So shift is negative. Every time I am going to write some positive symbols, but original answer is negative, because it shifts left side, so it's negative. Shifts opposite side, that's it, negative.